All right. So we start with the transmission line. So anyway, we know that whenever the name we hear as the transmission line, let me just take it to write. Okay, so let me write the side heading first. This is so as the name suggests, you are going to transmit something, right? And it's not a line; it's lines. That plural indicates that you have to have multiple lines. Okay, so that's what we find now. We might think that this is used for carrying a huge amount of power, something like that, right, that is true. That's also transmission lines only, but what we are going to study as a part of electronics is it may not be the addressing the same transmission line which is used to carry the power uh, from a power generating station to the cities. Okay, it's we are not exactly looking at that in this particular scenario because of our requirements are different. We want to learn something more, something other than the electric power carrying systems. All right, so here the fundamental idea is that transmission lines are used to carry the power, right, carry the energy from one point to the other point, right, but there is a uh, there's a condition. What we are going to study here has a condition, right? So these transmission lines, right, they are used to carry the high frequency, right, high frequency signals. All right, that's my first point, right? In the sense you use transmission, whatever transmission lines that we are going to study, right? We study all the characteristics, parameters related to the high frequency signal. That's our first point, right? Now you see, when I say I'll go a little bit deep here because this is important. When I say that I'm increasing the frequency of a signal, what happens to its wavelength? It keeps on reducing, right? I'll write in brackets. So f increases implies my lambda keeps on reducing because, right, they are inversely related, correct? Okay, now, so I'll try to bring another component here, that is the size of any object which you use in communication. Have you studied antenna somewhere? Oh, in the same subject, right? Sorry, I missed that. Sorry. Okay. So in that case, okay, since you don't have not uh, gone through that those concepts, I'll bring you one term here. So the size of any object that you use in communication as a dissipating device, right? As a transmission device or a dissipating device, for example, antenna, right? The size of that device, it can be transmission line or it can be antenna, right? There is a concept. Mainly we study that in normally in antenna, then we'll come to the transmission line. But anyway, in this case, it's slightly it's other way around. No problem. The size is proportional to the wavelength of the signal, right? That's the concept, right? So in the sense, if you want to use a an antenna for carrying very high frequency signal, right, the size is less, right? So again, if you see, if I use a low frequency carrier, antenna size will be huge, right? So that's why most of the time you see FM towers are large, right, compared to our maybe the TV dish antenna, which is smaller, right, because of the same reason. All right, okay. So now you see, I'm relating that, I'm bringing that concept over here. As I see the lambda is reducing because I'm carrying very high frequency signal. What do you expect? The size of this transmission line should be small, right? So that's what is my point. So I'm not studying a huge transmission line which are used to carry the power. So I told I'm using specifically for high frequency because of this reason. So whatever we study here, right, they have one fundamental characteristic, that, right, the here we see that the length of the perfect, right? So transmission line is a technical term I'll try to use here, right? The length of the transmission line is of the order of the lambda, or the wavelength of the signal that you are going to use for a transmission. Right. So specifically, again, we have we will later on we'll bring this down to a specific range of frequency called microwave range. Okay, where you have the highest usage of the transmission lines. Okay, it's they are very good because of their power handling capabilities, because microwave has a completely different scenario when it comes to its property, right? So microwave, the whole range, you see, it can be used even to cook food. At the same time, you will use it for the transmission of your voice as well. You see, right? So that's why I told it has a very wide, very variety of features available in that particular microwave frequencies. Okay, so ultimately we'll cut it down to the only those lambdas which are coming under the microwave frequency. Okay, fine. Now, so why do you need this? Fundamentally, anyway, we are not going to look at the microwave ovens building of that. So definitely we are going to use it as communication engineers. Definitely it will be applicable in the communication part. Okay, right. So whenever we build the devices, communication devices, right, our uh, fundamental idea is that how do you efficiently use the power available in the microwave frequency. Anyway, I'll use the term, I'll write the term, right? So microwave, right? So this means it's definitely used in the fundamental communications. So that means what is our objective, right? Our objective, fundamentally we have two objectives. One, the first one is efficient usage of power. Okay, and also we want to use the minimalistic equipments. I want to handle more power, does not mean that you have to use a lot of equipments from. So you will try to select or build those equipments which can handle the required amount of power, right? In the sense, ultimately you increasing the efficiency. That's all. Okay, the second point actually indicates the first one only, right? Okay, right. Right. So this also this means, right, the transmission line which you are going to use may be present in any part of your circuit. Actually, you see, we are not, as I already told, we are not looking at any of the parts where a high power transmission is used, like electric devices, right? So now that indicates that since the size of these transmission lines, what we are discussing, is very short, definitely it will be present maybe in a small part of your circuit. Some transmission device has an amplifier followed by an antenna, right? Between them to connect we cannot use a simple line, right? Simple wire cannot be used because it's not going to match. We have many conditions like input impedance, output impedance, etc. That will not match. It will lose the power, which whatever is given as input, it will lose the power. So that connection, right, the final connection just before the antenna should be very perfect, right, to carry the signal for without any losses, right? So for that reason, right, we are looking at that. So this actually, whenever I say efficient usage of the power, minimalistic equipment, etc., so where we see them at the very close to the antenna transmitting or the receiving antennas, right, the line connectors, right, there are some holders present, right, within that those part of the circuit. Everywhere you will see these microwave these transmission lines. Later on we'll cut it down to the microwave transmission lines. Okay, right. Now let's look at the next feature of this. So whenever we say that the transmission line is being used, that means, right, we have to have system of, it's not a single conductor, we call it as a system of conductors.